All right, so welcome to Unit 10, Lesson 1. This is about complex and imaginary numbers. So a couple of things. Imaginary numbers, let's get this over here. Imaginary numbers result from taking the square root or the even root of a negative number. Now remember, in Unit 9, we said that you could not take the square root or the even root of a negative number, and we said that was not possible or not applicable. But today, this unit, we're going to show you guys how that is possible. Okay, so here's something that you must memorize. The imaginary unit is I, and the square root of -1 is equal to I. Okay, please memorize that the I squared is equal to -1, I cubed is equal to -I, and I to the fourth is 1. These you must memorize. You'll be tested on it repeatedly. Okay, now square root of -1 will never be used in an answer only I. So never going to want to use this one. We're always going to change the square root of -1 to the variable I. Okay, a complex number. Any number that can be written in the form of A plus BI, where A is the real part and BI is the imaginary part. Okay, the conjugate of this is of A plus BI is a conjugate of A minus BI, and again, this is the conjugate of that. Okay, so only the imaginary parts change signs. If it was negative, it becomes positive, and it is positive, it becomes negative. Okay, again, complex numbers come in pairs. They come as conjugates. This is a conjugate of this, and this is also a conjugate of this right here. Okay, so let's simplify imaginary numbers. Okay, anytime we have the square root of a negative number inside, okay, it's broken down into two parts. The negative part, the negative sign, becomes the square root of -1, and whatever else remains, we're going to go ahead and deal with that. Okay, so let's really quickly start with some easy ones right here. Okay, the square root of -4. Well, we get the negative part becomes -1, and the square root of 4 is this. So square root of -I, or -1 is I. Square root of 4 is 2. So we multiply those together, we get 2I. Okay, look over here. 5 times the square root of -60. Well, first thing we do is we get rid of the negative sign. It comes out as the letter I. And then we go ahead and break down the 60 as 4 times 15. We know the square root of 4 is 2. 15 stays on the inside. Now it's 2 times 5i, which becomes 10i radical 15. Okay. Again, over here, we break this entire bracket down into the square root of -3 on top over the square root of 7. Now, first thing we do is we always, in all of our problems, the first thing we're always going to do is get rid of that negative sign on the inside of the radical and pull it out as an I, just like we've done here. Okay. Now, in Unit 9, we learned that we cannot have a radical on the bottom, so I'm going to multiply top and bottom by radical 7. Okay. So on the top, I get I radical 21 because 7 times 3 is 21. On the bottom, I get radical 7 times radical 7 is radical 49, which gives me the square root of 49 is 7. So that is our answer there. Okay. Page 2. Let's go ahead and look at the notes. There we go. All right. So step 1, always take out I first. Okay, first thing, take out I. So in this one, you would think that it's normally -7 times -7 will give you positive 49 under the radical sign. No. First thing you do is we take out the I. So the I comes out. Okay, -1 comes out as an I. The negative comes out as an I. So it becomes I times I is I squared. 7 times 7 is 49. Okay, square root of 49 is 7, and I squared changes to -1. This was from what I told you guys to memorize. Now, if you didn't memorize this stuff, go back and do it now. Okay, over here, okay. Again, first thing we do is we take out the negative as an I. Okay, now the I's got an exponent of 1, and the 5's got an exponent of 1. So we take multiply and multiply, so we get I to the cubed, 5 cubed, okay, and we're looking for I cubed is equal to -I. That's from our memorization right there, okay. 5 cubed, we can write it out as 555, and since the index is a 2 when it's not shown, I'm looking for groupings of 2, so I take that out, and it looks like this, okay. Again, that power to a power, it multiplies in, so it becomes 16i squared right there. And you've got 3i. Again, the real numbers multiply, so we get 48. I times I squared becomes I to the third. And we know that I to the third is equal to negative I. So 48 times negative I becomes negative 48i. Again, before we do anything, we pull out the negative sign on both of these to equal 4i radical 12, negative 2i radical 3. Now we're multiplying 4i and negative 2i multiplied to negative 8i squared. 12 times 3 is 36. Again, negative 8 comes down as that. I squared changes to negative 1. Radical 36 changes to 6. We multiply all this together, we get 48. Okay. Again, step 1, pull out the negative sign. Okay, it becomes 2i radical 72 minus 2i radical 50. And again, we simplify 72, simplify 50 as shown. We get this. Now look, we've got common terms, okay, or like terms. Because of the radical 2, we can go ahead and add and subtract the coefficients, which are 12i minus 10i, which gives us 2i radical 2. Okay. Now, how do we change? The best method for breaking down greater multiples or powers of I is this. Okay, we're trying to get them into groups of I to the fourth. Well, why I to the fourth? Because I to the fourth equals 1, right? So I can break the 10 down into I to the fourth times I to the fourth times I squared, because I to the fourth and I to the fourth are 1 and 1, and I squared is negative 1. So the answer is negative 1 times negative 1 is negative 1. A faster way of doing that instead of breaking down is let's divide the power right there by 4. And they're always going to divide by 4. The divisor is always going to be 4, whatever that power is. So 4 goes into 10 2 times with a remainder of 2. Now the remainder is what becomes the new power, okay, for I. And I squared is negative 1. Again, what is I to the 12th power? Well, 4 goes into 12 3 times with the remainder of 0. And I to anything to the 0 power is always 1. Next part, okay, I to the 55, again, take 55 divided by 4, always divided by 4. 4 goes into 55 13 times, okay, with a remainder of 3 at the very end. So the 3, which is the remainder, becomes the new power of I, okay, and I to the third power is negative I. And finally, okay, 4 goes into 209 52 times with the remainder of 1. Again, the power goes there, and I to the first power is the same as simply I. Okay. Now, complex numbers, multiplying. Okay, we're going to FOIL this out. Okay. 8 times 2 is 16. 5i times 2 is 10i. Okay. And then we go 8 times negative 3i, it becomes negative 24i. Okay. 5 times negative 3 is negative 15. I times I is I squared. Again, I squared changes to negative 1. And we get a positive 15. Again, now we can combine like terms, and we get 31 minus 14i. Over here, same thing. Because it's squared, we write it out twice. We go through the same process. Okay, we combine like terms over here. Becomes negative 60i. Okay, 6 times 6 is 36. I times I is negative is I squared. I squared is negative 1. So that becomes, instead of positive 36, it becomes negative 36. Combine that with the 25 gives us negative 11. I am going to try flying through this a little bit quicker, just because to save time. Again, when we're adding these things, make sure if there's a negative sign, go ahead and distribute that negative sign in, and then go ahead and combine like terms. Okay? If there's a positive sign between them, don't worry about it. Just go ahead and drop the parentheses and combine like terms. You may want to take a moment to pause the video and copy this down. Okay? Let's find the conjugate of this. Again, as we stated on the first page, the conjugate changes only the sign on the imaginary part. The real number stays the same, and the sign on the imaginary part changes. Okay. Now here's this number right here, negative I. Well, what's a real number? That is with it? Well, 0 minus I is how we write this as a complex number. And again, the only part that changes sign is a number, or is a sign in front of the imaginary part. So that becomes positive 9i. Okay? And 15 is the same as 15 plus 0i, because again, all complex numbers have a real part and imaginary part, and this part that changes is the negative on the imaginary part again. So it really changes nothing for a constant like that. Next part is to find the product of complex number and its conjugate. Now here's a quick little trick. Okay, when we do this, when we multiply this number by its conjugate, 7 minus 2i, 7 plus 2i, the trick is this. Look at this, 7 squared is 49, I, negative 2i times positive 2i. We square that and we lose the I, so it becomes the square root of the first term plus the square root of the second term and lose the I. 49 plus 4 is 53. That's a quick little trick. If you need to see the work, go ahead and look at this and check it out. Okay. Now, just as in Unit 9 we couldn't have a radical on the bottom, we cannot have an imaginary I on the bottom, so we must multiply that out. Okay, I'm going to multiply top and bottom by I to get rid of the I on the bottom. We get 3i over I squared. Okay, 3i stays the same. I squared is negative 1, and we can write it as negative 3i. Okay, and again, you guys can go ahead and add these notes in by pausing the video. I'm going to kind of go through this quickly. Okay, again, first thing we do is we take out the negative sign as a 2i. And again, we can't have a radical or we can't have an I on the bottom, so we multiply both top and bottom by radical I radical 6. Okay, we follow the steps right here. Square root of 36 is 6. I squared becomes negative 1. We multiply the bottom of that. We get negative 12 over under 15 I radical 6. Again, the negative 12 and the 15, we can reduce that to 5 over negative 4. Okay. Let's go to FOIL this last part out. Okay, again, we multiply top and bottom by the conjugate of this. Okay, so the conjugate of 3 minus 4i is 3 plus 4i. Okay, and I told you guys the quick little trick when multiplying by conjugates is square of the first number plus the square of the second. So 9 plus 16 gives me the 25. Okay, again, if you don't feel comfortable doing that, go ahead and FOIL it out. Top part, we are going to have to FOIL out this number times this, so we get this entire thing written out first. We combine the like terms, and the back term is always going to end up with an I squared, which will cause it to change the sign and combine with the very first term. So 6 minus 4 is 2, and that's our answer. Okay. Again, we're going to multiply by the conjugate. Okay. 5 plus I radical 3 is the same as, or is multiplied by I minus 5 minus I radical 3. Again, the square of the first term plus the square of the second. Well, 5 squared is 25. Radical 3 squared is 3. So our bottom term is going to be a 28 right there. Okay, and we're going to have to FOIL out the top. In this part, you will have to do work. There is no shortcut to it. We work it out. And again, we combine like terms because they both have radical 3 as the like term right there. I squared becomes negative 1. Square root of 9 is 3, so that's a negative 3. We add it to the 10, that gives us the 7. Okay, and again, we can go ahead and pull out a 7 right there out of the top and then simplify. So this is the final answer. This would be a 3 out of 4 on a test. This is a 4 out of 4 on the test. Okay, find the multiplicative inverse of imaginary numbers. Okay, step 1 says take the reciprocal. Step 2, multiply by the conjugate of the denominator. Step 3, simplify. Okay, so let's get the multiplicative inverse. Step 1, get the reciprocal. So flip it over. Okay, now multiply by the conjugate. Okay, again, first term squared plus the second term squared, which gives us 49 plus 4 is 53 on the very bottom. Okay, and FOIL the top parts together. 1 times all this, will just going to be just that. We cannot pull out anything out of the top to simplify with the 53, so that's the way it stays. Okay. Again, find the reciprocal, multiply top and bottom by 2i. Now you could multiply just by I and get the same thing, right? Because that's all we need to do, but you can multiply by 2i. I'm just showing you guys how to do that. Okay, so we get 5 times this, so we get 10i minus 6i squared over 4i squared. Okay, then we take that I squared, change it to a negative 1, and then we reduce by 2. You notice that if you multiply just top and bottom by I, you would not have to reduce. Okay, whereas since you multiply by 2i, you would end up having to reduce. So be careful on that. If you multiply by more than you need to, you'll end up reducing. If you do it the right way, short way, you will not have to reduce. Okay. Find the values of x and y to make the equation true. Well, we match up the real parts and we match up the imaginary parts. Okay, so we can say a plus bi equals c plus di. Okay, and a matches up with c, so I can say 3x is equal to 12 and solve for x. Then I can write 4y is equal to 8. We get rid of the i's temporarily when we're solving for this part, and we can say y is equal to 2. Okay, again, match up real to real, imaginary to imaginary. Okay, it's 4x is equal to 12. Okay, and 9y is equal to, well, there's no other imaginary part, so we can say it's equal to 0 and solve for that. Okay, quadratics, solving quadratics. Okay. First thing, we go ahead and subtract out the 8 when we're solving for y. Divide by 5, negative 8 divided by 5, and we take the square root of both sides. Okay, now this is going to be a plus or minus answer. Okay, so I can take the radical and break it up into the radical 5 over the radical negative 8. Again, first step is to pull out the negative into an I. Now we have I, radical 8 over radical 5. Again, can't have the radical on the bottom, so multiply top and bottom by radical 5. We get radical 40 over 5 times 5 is 25. Square root of 25 is 5, right? Again, 40 can be simplified into 2 radical 10. So this is our final answer. Okay, let's go ahead and do this one. Minus 48. Divide by 6, well, negative 48 divided by, negative 42 divided by 6 is negative 7. Take the square root of y squared, take the square root of negative 7, and the I comes out, and you'll have to plus or minus I radical 7. Okay, and that is it for the notes for this.